Hi everyone, welcome to our Team Super Mario presentation of our DIY mini vacuum cleaner for a recycled material project. So why this project? As engineering and project management students, we saw two pressing issues. Many Orang Asli students lack of the access to hands-on STEM learning, with only 56 of them completing their secondary school. At the same time, our community is facing the rising of plastic waste, so we created a DIY mini vacuum cleaner using the recycled materials like plastic bottle. This project is simple, low cost, and able to teach core engineering concepts like airflow and circuitry through 5E models to our Orang Asli youth. By blending sustainability with family-friendly learning, we hope to make science fun, practical, and more inclusive to our Orang Asli youth who deserve more chance to explore STEM. In our project, we set out to achieve 5 core objectives. We want to inspire creativity, promote sustainability, focus on accessibility, encourage family bonding, and also introduce basic engineering concepts through hands-on learning. So these goals are guided by the SMART framework. The project was specific to guide 9 QA students to build the DIY mini vacuum cleaner by recycled materials. It was measurable with 10 question quiz conducted before and after the workshop. It was achievable as it is within a small budget and built by simple and safe tools. It was highly relevant at it addressing a real educational gap for our Orang Asli youth. And lastly, it was time-bounded as this project was successfully implemented on the 18th of May 2025.
Our project involves strong collaboration with key stakeholders. IEEE Malaysia support us with funding and technical advice, while JAKOA facilitated communication and access to the KOA Kampung Pantai community. The Orang Asli villages themselves play a vital role as active participants, and our UKM lecturers provide constant guidance throughout the process. We engage the community through site visit, briefing, and discussion sessions to ensure the project was relevant, respectful, and mutually beneficial. To manage the project effectively, we follow a structured work breakdown, structured across 5 phases: initiation, planning, execution, monitoring, and closing. Each phase had clear deliverables, from setting goals and creating prototypes to running the actual workshop and collecting feedback. Tasks were divided based on our roles: CEO, CTO, CFO, and coordinators, so that each team member could contribute according to their strength.
Our project kicked off in March 2025 with goal setting, team formations, and planning, including soil and pasture analysis. We completed the first prototype and submitted our project plan by early April. The July April was focused on refining the prototype, sourcing materials, and preparing teaching kits. The outreach sections at QA took place in mid-May. We have stayed on track with our timelines, and from late May to June, we are wrapping up with reporting, video documentation, and reflection. For cost efficient and sustainable, each stem kit costs around 6 ringgit and 40 cents, covering key components like a DC motor, fan blade, battery holders, battery, wire connector, and filter. Share tools and shippings are not included per kit since they are used across the project. We kept cost lows by using recycled items like water and straw, and by purchasing essential parts. Funding came from the IEEE Malaysia STEM budget to ensure affordability while maximizing the learning impact.
Our DIY mini vacuum cleaner will design using easily accessible and recycled materials. The main components include a recycled plastic bottle, a DC motor connected to the fan plug for the airflow, a battery pack, a switch, and a mass filter. With the power on, the motor spins the fans and creating a suction that pulls in the dust through the bottom of the lid. The wires are connected in the reverse correctly, means that the positive to the negative, to ensure the fans spin in the right direction. This project introduced the student to the basic mechanical and electrical concepts like the air pressure, the motor control, and sustainability to the hands-on. To support our project's feasibility, we use the SWOT and the pasture analysis. Our strengths include hands-on advance for the student to promote the STEM learning, low-cost design that promotes the eco-awareness. However, we faced our weakness like the material inconsistency and the limit suction power. Opportunities with the NGOs and the school STEM workshop, while the threats include time constraint and the material availability. From a personal side, political support from the JAKOA and the IEEE, and the budget-friendly step-up practice affordable. The simple technology encourages the STEM learning, while the use of recycled materials teach the student about the sustainability. All done simply under the supervision and following the STEM guidelines.
On May 18, 2025, we conducted our workshop at Kampung Orang Asli, Kampung Lenggeng in Negeri Sembilan. We started by showing them a short video and asking simple guiding questions to spark their interest. Then, each student received their own DIY mini vacuum kit made from recycled materials. Facilitators guided the participants step by step while ensuring a safe and encouraging environment. We were also pleased to see parents joining in, observing and supporting their children's learning. It created a positive, community-focused atmosphere. Although we originally planned for 15 students, only 9 participated, and that allowed each student to have their own complete set. The impact was clear. More than 80% of the students improved their quiz scores by at least 30%. The feedback was overwhelmingly positive. Many students say they enjoyed the hands-on approach and were proud of their finished vacuum cleaner. Parental attendance also added value by reinforcing the learning environment and creating meaningful shared experiences. Overall, the workshop successfully sparked interest in STEM, and sustainability, all through a simple, fun and effective DIY project.